Welcome. In this walkthrough, I'm demonstrating the Generative AI DLP Gateway in an enterprise-grade enforcement layer that sits between users, AI models, and vector stores. This system operationalizes AI governance, prevents unauthorized data flows, and produces auditor-ready evidence every time it runs. I'll start by entering a prompt. The moment I click Run, the request hits the DLP gateway, which performs entity detection and classification using regex-based rules and contextual MLQs. The gateway determines whether the content is internal, restricted PII, or restricted PHI. You'll see the detected entities and the final classification label rendered here. So I'll go ahead and click Run DLP and RAG Flow button here. We've already have a prompt that's pre-loaded to enter. And as you see, a DLP classification with the label internal. We have our data movement decisions section here, which we'll get into later on in this presentation. We have the RAG retrieval coming from Pinecone, which gives the assistant explanation. We also have the vector ID, meaning the data that was entered from an S3 bucket, which was upserted into our Pinecone RAG. We have a score that's given based on the sensitivity level, so the classification. And here is the reference of the S3 bucket key. So it's coming from our clean folder inside our S3 bucket. Further down, you can see there would be an AI assistant response if there was sufficient information here. Being that there's not enough sufficient information, you see that it will respond with I have insufficient information. Further down, you see the evidence snapshot for GRC. This is where map unified controls to my OPA policies and checkoff checks. As you see, you'll see an ID. These were created by me. You have the name of the control that this is mapped to, a description, the domain, the requirement, meaning shall or should. You also have the frameworks listed here. So we have ISO 27001, version 2022. It's referencing A.5.1 and A.5.2. We also have ISO 42001, version 2023, which references 5.2, clauses 6.1 and 6.3. We also have inputted the ISO 27701, which also references clauses 5.2.1 and 5.3.1. And finally, we have HIPAA security, being that you'll see some medical information as well for our healthcare industry or insurance industries who would be more prone to HIPAA-based compliance. Here's the tools that are being used within the development back end, where we have OPA policies being referenced in our governance directory. We have our checkoff checks that are running the scans. And here's the evidence where it sits, which creates our evidence bundles for our GRC team for compliance. And as you scroll down, you'll just see more of these particular frameworks and control mappings, like roles, responsibilities, and separation of duties. You have risk assessment for data and AI workloads. You have data classification and labeling. And as you see, the domains are also here, technical. So this is just a preview of a prompt and a DLP sitting here to decide on the data movement decision. Now let's talk a little bit about the OPA policy enforcement. Next, every hop in the workflow is evaluated by an open policy agent. We validate the chain where there's user prompt entering into the DLP gateway. And if it's internal and it doesn't have a sensitive label applied to it, the allow would be true to then flow into our Pinecone RAG. Next, we have the DLP gateway to our RAG orchestrator, and you see the same here, it's allowed. And finally, we have the RAG orchestrator that would go into Pinecone, which is also allowed. Each hop is checked against flows.json and data-movement.rego policies that I have implemented in my backend. So the open policy agent enforces strict information flow rules. If a hop violates classification boundaries, for example, restricted PII is not allowed to leave the gateway, OPA returns allow false with a human readable explanation describing exactly which rule fired. This gives CISOs and auditors full transparency rather than AI guesswork. Before we go deeper, here's the supporting architecture that makes the controls enforceable. So I'll show you. Here's my DLP utilities that I sit into my DevSecOps directory here under Python. And this is my core classifier and where OPA also is my runner. And just a few definitions, definite functions here. We have the entity detection and classification section, then the backwards compatible API for my test, like detect PII, and my OPA bridge, which runs the OPA, Open Policy Agent. And we have special cases, which is the RAG to the LLM, which is the OpenAI LLM that we're using. Next, we have my MLSecOps directory where my data movement sits. So policies like flows.json here would show my user to gateway internal. My conditions would show here based on the classification label. So from the user to the DLP gateway, and also from the DLP gateway to RAG orchestrator. And this is the gateway to RAG internal, right? We also have the RAG to Pinecone internal, and this is from the RAG orchestrator to Pinecone. And we either allow, mask, or block. But here, for demonstration purposes, we're just allowing or masking. Then we have our Streamlit app, which is the live governance UI. So as you see, we have my Pinecone connector here. We also have my helpers, so it would embed the text. We would query the RAG, so we would query Pinecone. We would simulate the flow here, and that is what would show up in the front end. And our AI using OpenAI, our OpenAI API key would then summarize the RAG results, and among other steps here. And here is my CI/CD pipeline. So this runs the unit test, the open policy agent policy test, the checkoff scans on Terraform, and builds unified evidence bundles on every commit. So the demo you're seeing is backed by the same controls required by ISO, HIPAA, and NIST AI RMF. Now back to our UI. If the classification passes and all hops are allowed, as you see here in our data movement decisions, We embed the prompt into OpenAI and submit it to Pinecone, as you see in the last RAG orchestrator into Pinecone. Now, the RAG system responds with top matches and governance aware AI explanation. If even one hop is blocked, the RAG flow is terminated. This ensures zero chance of PHI or PII leaking into vector databases. So I'm going to go ahead and demonstrate again. As you've seen earlier, the DLP labels, this is as internal. No sensitive entities are being detected. OPA evaluates all hops, which each one is allowed. So RAG executes as expected, as you can see here, and you'll see the Pinecone results down here. The assistant also returns either it could return atlas-based context, explaining why the retrieve entries were selected. This makes the RAG system traceable and explainable, which is a requirement in ISO 42001 and the NIST AI RMF. Now, let me show you some sensitive prompts here. Give me one moment. So here's a prompt here. Now, as you can see, the classifier detects the SSN entity and labels this prompt restricted PII. Now, watch the data movement panel. OPA sees restricted PII, it checks the flow definitions, and it blocks the hop to Pinecone, as you can see here, and returns the exact deny rule and reason. This is the governance guarantee. Sensitive data dies here and not downstream. Now, behind the scenes, every decision is logged and merged into an auditor grade unified evidence bundle. Our evidence pipeline consolidates OPA runtime decisions, Terraform plan evidence, checkoff infrastructure as code compliance results, data movement logs, classification logs, RAG metadata, and critically, the Unified Control Catalog mapping to ISO 27001, HIPAA, ISO 42001 are OPA and checkoff rules. So, as you see, here is the generated evidence unified JSON file. You'll see run metadata, full control mappings, tool coverage, and structured evidence, everything an auditor, CISO, or regulatory reviewer needs, generated automatically. In closing, this is the first fully integrated DLP, OPA, and RAG governance layer designed specifically for enterprise generative AI workloads. It enforces policy with precision, blocks unsafe flows, and produces verifiable audit evidence, all in real time. Thank you for watching. Please like, share, and subscribe. Have a good one, everyone.